All right, 7-3. Some basic statistic information. We're going to go over mean, median, mode, variance, and standard deviation, how to calculate all this. So I'm going to show you the actual way to calculate all this, and then in class I'm going to show you guys another way to do it. So let's go through some basic stuff here. We have some terms here, what stats are, measure central tendency. That just means that, like, if you have a whole bunch of people doing something, or a whole bunch of anything, birds, a whole bunch of bugs, a whole bunch of money, anything, what do they, on average, what's the tendency tend to be? Mean. Okay, this is just another word for average. It's the sum of the numbers divided by n, some n numbers. And the mean is denoted by this symbol. This is really important that you know this. This is going to show up a lot. It looks like that. And we just call that the x-bar. Median. This is the middle of n numbers. So you have to put them in order from least to greatest. And then it's the very middle number. And mode, and this is the most frequent number. It's the number that occurs most often. So I'll show you some examples of that. But if like one number just keeps showing up or shows up more often than the others, then that's the mode. And there could be more than one mode. There might be like a tie, a two-way tie, or three-way tie, or something like that. That's possible. Okay. So let's take a look at this first data set. It's already in order for us. That's very nice. And we're going to find the mean. And that's not so bad. We just literally add all these things up. 4 plus 7 plus 8 plus 8 plus 9 plus 9 plus 10 plus 11 plus 12. And then we divide it by how many numbers there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to divide all of that by 9. Now, when you do that, you should get about 8.6 repeating. All right, there's the mean. How about the median? The median is the very middle number. The very middle number. So as you go through, if there's 9, the middle number would have to be the fifth number. So 1, 2, 3, 4, 5. That's the middle number right there, 9. So the median is simply 9. Now mode. Mode is the number that occurs the most frequently. Well, I have 2 8s and I have 2 9s. So there's 2 modes here. It would be 8 and 9. Those are both the modes. Simple. Okay, so that's how you do those 3 things. I think you could do that for race B. I want you to go ahead and just pause the video and try that on your own. Okay, so if you add all the numbers up, divide by 9, there's 9 numbers again. You get 7.6 repeating. The middle number, again, they're already in order. So the middle number is the 5th one out of 9. That would be the number 8. And then also the mode is 8 because 8 occurs 3 times. All right, 6 occurs twice, but 8 is the most. So that's the mode. Okay, let's move on. A couple other terms here. Measure of dispersion. A statistic that tells you how dispersed or spread out data values are. So there should be a how right here. Range. The difference between the least value and the greatest value. So like, for example, up here, the range here would be, you could write it a few different ways. I usually like to write it as like a interval. We could say it's from 4 to 12, and we're including 4 and 12. And then the range here, we could say it's from 5 to 11. Okay. The typical difference or deviation between a data value and the mean of that data set. Standard deviation is represented by this little like O with a tail symbol. This thing right here. We're gonna spend some time calculating that, okay? That's a symbol for standard deviation. So let's talk about how we do that on the next page. Let's go. All right. For this one, we're gonna use the same data set that we already used. And I'm gonna show you exactly how to do that. But what I would recommend is you kind of make like a list. So it says find the mean of the data set. We actually already did that on the previous page. If you remember, this was 8.6 repeating. And then for each number, subtract the mean and square the result. Oh, okay, let's do this. So I'm going to show you how I would do this. I'll make a list. Oops. So 4, 7, 8, 8, 9. And we really actually don't have to put these twice. So, I mean, you don't have to calculate them twice, though, obviously, because you already have it once. I'm going to make like a little chart here. You'll see why in a little bit. Okay. And I'm just going to call this my like xi, meaning like my x term, 1 term, 2 term, 3 term, so on. All right, now the next thing they say is to subtract, for each number, subtract the mean and then square the result. So let's do the subtraction part first. So I'm going to do that term minus the mean. And you're probably going to want a calculator handy. And so 4 minus 8.6 repeating is negative 4.6 repeating. And then 7 minus that is negative 1.6 repeating. And then 8 minus 8, that's going to be negative 0.6 repeating. And then obviously that's the exact same thing. And then for 9, it's going to be, let's see. Oh, that's going to be exactly 0.3 repeating, or 1/3. By the way, this is also negative 2/3, if that makes your life easier, which it might. Oh, I put 1/2. I meant 1/3. Or we could say 0.3 repeating. For 10, it would be 1.3 repeating. For 11, it would be 2.3 repeating. So 1 1/3, 2 1/3. And then for 12, it would be 3.3 repeating, or 3 1/3. All right, and then the next thing it says is to square this number. Take all these numbers and square it. So now I'm going to do this. All right, now this might take you a little bit of time. You could do this in your calculator, and maybe you want to do this like one step at a time. You do 4 minus the mean, and then you square it. And then you can do the next number. But here, I already did this, so I'm just going to tell you what you end up with. You end up with 21.7 repeating, 2.7 repeating, 0.4 repeating, 0.4 repeating, 0.1 repeating, 0.1 repeating. It kind of looks like a T, so I'm going to clean it up. 1.7 repeating, 5.4 repeating, and 11.1 repeating. Okay. Now, here's what we have to do. Let's go back up the directions. Now what we have to do is we have to find the mean of those square differences. So we're going to take the mean of this, and then we're going to take a square root. That's how this works. So basically, we add all these up and divide by 9. So I go down here. Essentially, it'd be like 21.7 plus 2.7 plus ... plus 5.4 repeating and plus 11.1 repeating. So I'm just kind of shortcutting writing all this. And there's still 9 terms. So I'm going to divide by 9. And then it says you take the square root of that. And that is how you get your standard deviation. So if you do all that right, you should end up with a standard deviation of 2.211. About that. That's what I got when I did it. Now, that's a lot of steps. So we can actually denote all those steps in a formula. So let me show you what that looks like. Looks like this. Standard deviation is the square root of. This symbol right here just means the sum. And we're going to say from the first term to whatever the last term is. In this case, it was first term all the way to the 9th term. And we're going to add up this. What we're going to add up is the first term, or each term, minus the mean squared. But then remember, we're adding that all up and we're dividing by the number of terms. So this just means you do this as many times as you have terms, like we did over here. So essentially, this whole sum part right here is what I did all down here. But that's the formula. Now, this, just so you know, this formula right here is when you have the whole population. So when you have, I'm going to write population, or basically when you have all the data. There's another formula that's very similar to this, and this is when you only have a sample. What that means is, let's say there's actually like thousands of races, but I only picked 9 random ones. Well, now I would only have a sample of that amount. And so the formula is slightly different. I think we're usually going to be using the population one, but I just want to show you what the sample one looks like. It looks almost the same. Still doing the sum, from the first term with each term minus the mean and then squared and then divided by n, except for it's not just n. What you do here is you do n minus 1. That's all the formula changes when you're going to do the standard deviation for a sample. And that's all that's different. Okay? All right. So we did all that. What I'd like for you to do is try it with raised b. See if you can do it all on your own. Might take you a little bit of work, so pause it and work it all out. I'll fill in the chart here after you do the work, and we'll see if we get the same result. Okay. All right, so I listed all my terms. I took each term and subtracted the mean that we got on the previous page. Then I took all these numbers and I squared them, and then we added them all up and divided by 9, and then took the square root of that, and that gave me the standard deviation of 1.826. So fun, right? Okay, let's go to the next page. All right, so now just a couple other things. So now let's take a look at this problem. We're going to talk about outliers. Outliers is a value that is much less or greater than all the other data values in the set, and just kind of show you what that looks like. So let's say you're training for a triathlon. The miles that you ride your bicycle for 7 weeks are shown below: 17, 20, 16, 18, 22, 19, 20. Now, the first thing I would do is actually put all this data in order. So zoom in a little bit. So the lowest number is 16. And then the next number, and I'm going to cross off as I go through it. The next one is 17. There's only one of those. The next one is 18. There's only one of those. Then 19. There's only one of those. And then there's two 20s. And then 22. Okay, cool. I got my data set here. And they want us to find the mean, median, mode, range, and standard deviation. We're going to do standard deviation last. Let's do these other ones first. It's not so bad. The mean, that's pretty easy. We're just going to add these up and divide by the total number of terms, which there's 1, 2, 3, 4, 5, 6, 7. So if you do that, we get, again, I'm just writing the shorthand because I know you're going to do this in the calculator, and then eventually you're going to add the last two terms, right? All out of 7. And when you do that, you should end up with a mean of, I'm getting 18. And I don't know if you recognize that decimal pattern, but that's actually a pattern. It is 8, 5, 7, 1, 4, 2. And that actually is a repeating pattern. And that actually is this weird, is from 7 as the denominator. So this is actually 18 and 6 sevens. Nice, neat, rational number, even though it doesn't look like it, but that does repeat. And we know it's out of 7 because we divided by 7, so we should get a rational number. Okay, what's the mode? Well, that's easy. There's only one number that shows up twice, so the mode is 20. Oh, the median, we could do that too. The median is the middle number. Looks like it's 19. So let's do the median. It's 19. And what's the range? We know it goes from 16 to 22. All right, so we got mean, median, mode, range, all pretty easy. Standard deviation takes a little bit more work. So we're going to take all of these values. Remember, I'm going to write up here each term, and we're going to subtract the mean. And let's fill that in as we go. So I already did it, and I got negative 2.857. I'm just going to write these digits. This is still the same pattern. So this is like 6 sevenths. Then I got negative 1.857, and then I got negative 0.857, and then I got 0.1429, which also, this is also a repeating pattern for, I believe, 1/7. And then 1.1429, and then another 1.142, that's a 2, 9, and then 3.1429, which is not pi. This is 3 1/7, just so you all know, 3 1/7, or another way of thinking of this is 22/7. And what's interesting is that this is actually really close to pi, but it is not pi. And so for a long time, people thought this was pi because it's pretty close. It'll actually do really well for most things. Okay, all right, next step is to square each of these numbers, right? So I got to take each of these and then square them. Okay, when I do that, I get 8.163, 3.449, 0.7347. I did all this already in the calculator. That's what I'm doing. It's going to take you guys a little bit of time to crank all this out. You just got to do it. But I'm just square. All I did is literally, as I did this, I squared it. I wrote it down on my paper. So I'm just literally copying it down from what I wrote down. And then I got 1.3061, and then I got another 1.3061, and then 9.878, I believe is what I got. Okay. All right, remember now, for standard deviation, I take the average of this, or the mean of this, and then I take the square root. Isn't that fun? So, standard deviation equals the square root of 163 plus 3.449 plus ... until we get to the last term, 9.878. Running out of space. Boom. All over n, which is 7 in this case. And when you do all that, you end up with, I got about 1.88. All right. And you know what? Next video, you might be wondering, what the heck is standard deviation? We're actually going to talk about that, why that matters. Because if we know the standard deviation, we actually can know where a certain percentage of our data will fall. We can just know it. There's like a rule for it. It's called the empirical rule. I'm going to play with that next video, but that's why this is so important. But for now, we just got to figure out how to calculate this. Okay. Well, we did all those things they asked for. We got all the pieces. I'll put a box around all this because they wanted all this, and they want a standard deviation. Again, standard deviation is the most work. What I want you to do is do it all again, but now I want you to include a 3 in your data set. Okay, so all this is already done for you, right? You can literally copy all this down, but you're going to include a 3 up here. It's going to change your mean. It's going to change your range, and it's going to change a little bit of this. And then find all the new information. Okay, I want you to do all that. Obviously, now you're going to have 8 terms, right? So your n isn't going to be 7 anymore. Now it's going to be 8. So work all that out, and then check back to see if you get the same answer as me. Okay, when you work all this out here, I went ahead and copied all the data we had from the first problem here. And then when you work all this out, this should be your new information. This should be your new mean, median, mode. The mode doesn't change because there's still 20 is the thing that shows up the most. Your new range, and then your new standard deviation. And what they want you to see is what was affected a lot and what was affected a little bit by this. And if you're not sure how I got these, let's talk about it in class, and I can show you where I got this. But it's same process as here, but now I have one new number to throw in the mix. So which measures of central tendency does the outlier affect the most and the least? Okay, so for most, what did it affect the most? Well, that didn't change. I mean, it changed a little bit. That barely changed. By the way, the median, if there's an even amount of numbers, you just pick the number in between your two middle numbers. The mode didn't change at all. The range changed a lot. Right? That's a big difference to go start at 16 and start at 3. And the standard deviations changed a lot. And you might just see that written as SD. What about the least? Well, the things that affected the least were the mean. That's just, I would say, a little. The median, barely. It barely changed. The mode, not at all. No change. And that's it. All right. And what effect does the outlier have on the range and standard deviation? So let's see. So for the range, we would say it widened it. substantially. Because if you think about it, we only were going 16 to 22. That's only 6 digits, 6 apart. Or maybe you could say 7 apart. And now all of a sudden we're like 19 apart. So that's a big, big difference. And then on the standard deviation, what did it do? Well, it almost tripled it, right? Actually, that might be about triple. So I would just say it about tripled it, which is pretty significant. Okay, and we'll learn more about why this matters later on, but just wanted to show you guys how to calculate standard deviation mainly, and to kind of see how an outlier can affect some of this information. All right, see you guys in the next video.